Okay, in this problem, this is a buffering capacity problem. I could refer to these as busting the buffer. What we have is a formic acid. I have 500 mils of 0.15 formic acid. So I've shown you up here that that's going to leave me with a calculation of 0.075 moles of that. And I have 500 mils of a 0.2 molar NaPho. Now, we aren't worried about that Na. It's a very weak acid, but we're worried about that conjugate base. That's going to be 0.10 moles here. To that, we're going to add 10 mils of 12 molar formic acid, sodium hydroxide. And I'm going to add that over on the acid side. I'm not worried about the sodium. That base, and that's going to be 10 mils of 12 molar, which is 0.12 moles of that. So now if I look at the stoichiometry of this, 0.12, 0.075, the 0.075 is going to completely react, and what we're going to be left with is 0.045 moles of this. Now, that 0.75 also came over here and reacted and made 0.175 moles of the formate, but we have a strong base in hydroxide and a weak base in the formate ion. So now what's going to control my pH is this 0.45 moles of OH minus that's sitting in 0.510 liters. That's going to give me a concentration of 0.88 molar OH minus. So I can get a pOH equal to negative log 0.088, 1.05. Find out that the pH of this is 14 minus 105. Our pH is 12.95. And I can tell you from a previous problem that the pH of this buffer by itself was about 3.8. So we've clearly exceeded the buffering capacity. All the acid reacted, and all we were left with was a base and a pH to prove it.